So this will be a negative 3, a negative 3, and a positive 6. Okay, let's combine like terms. So you've got a 2x to the fourth and a negative 3x to the fourth, so that'll be negative 1x to the fourth. You've got a positive 1x cubed, negative 3x cubed, so that's going to be a minus 2x cubed. And then you've got blah, 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 6x squared, and then a plus 12x, and then a plus 6. That's going to be all over x cubed plus 6 squared. I'd actually leave it like that. If you wanted to, you can multiply out the bottom. You can. I wouldn't. But you can if you really want to. If your little heart desires, you surely can. Now, I'm going to give you a hypothetical situation here. Hypothetical situations are always fun because nothing is ever for sure. We don't know anything for sure. So, for example, number 4, determine if h of x is increasing, decreasing, or constant at x equals 3. And then it tells us that h of x is f times g, f of 3 is 5, g of 3 is 6, and f prime of 3 is negative 2, and g prime of 3 is 1. What? Then determine the same for t of x if t of x is f of x divided by g of x. What? Okay, let's look at what they're actually asking us. It says determine if f of x is increasing, decreasing, or constant. Forget the rest of this jazz for a second. Tell me if h of x is increasing, decreasing, or constant. What are they wanting to know? They want to know if my slope is positive, negative, or a number. Or 0, rather. Positive, negative, or 0. Well, let's figure that out. If h of x, I'm going to have to write a little bit smaller here. If h of x is f of x times g of x, I'm going to use the product rule. H prime of x is going to be f of x, g prime of x, plus g of x, f prime of x. Okay? Now, I'm trying to find it at 3, right? I'm trying to find h prime of 3. I want to know the slope at 3. So that's f of 3, g prime of 3, plus g of 3, f prime of 3. Well, they gave us all that information. H prime of 3, they just told us that f of 3 is 5. Right? G of 3 is, g prime of 3 rather, is 1, plus g of 3 is 6, times f prime of 3 is negative 2. So don't be scared by this question. It's really not that crazy. They just want you to set up the product rule and then fill in the stuff they gave you. So what's that going to be? F prime of 3 is 5 plus negative 12. It's negative 7. So let's justify that. H of x is decreasing at x equals 3 because h prime of 3 is less than 0. It's negative, right? It's negative. So that wasn't too terrible. They just want me to set up the product rule, and then for t of x, they want me to set up a quotient rule. So let's set up a quotient rule. From the top, let's just jump straight to t prime. F of x divided by g of x. So it's going to be g of x times f prime of x minus f of x times g prime of x. bottom d top minus top d bottom over g of x squared. Well, let's fill in all that stuff. I want to find t prime of 3. So that's going to be g of 3, which is 6, times f prime of 3, which is negative 2, minus f of 3, which is 5, times g prime of 3, which is 1, over g of 3, which is 6, squared. T prime of 3. This is negative 12 minus 5 is negative 17 over 6 squared is 36. So what do you think? The derivative at 3 is negative 17 over 36. What does that tell you about increasing, decreasing, or constant? It tells you your derivative is negative, so t of x is decreasing at x equals 3 because t prime of 3 is less than 0. So that's not too complicated. All they're asking you to do for h of x is set up a product rule. All they're asking you to do down here is set up a quotient rule. And there we have it. Product and quotient rule. Both awesome tools. If we can use them, if they do apply, they're awesome, awesome tools, and you are more than welcome to use them.